Today we are going to learn about AI ethics, building transparent AI systems. We will explore principles for developing AI systems that are both explainable and transparent, equipping you with the skills to implement these in practical settings.
Welcome to our session on AI ethics, building transparent AI systems. In the world of artificial intelligence, transparency is not just a buzzword but a critical component. It ensures accountability, builds user trust, and is central to the development of ethical AI models. Today's session will guide you through the essentials of creating AI systems that are both transparent and explainable. We'll cover practical insights and techniques, providing you with the necessary skills to implement these concepts in real-world applications. Let's dive in and explore the fascinating world of AI transparency. Transparency in AI is crucial for several reasons. Firstly, it plays a pivotal role in ethical AI development. When AI systems are transparent, it becomes easier to understand the decision-making processes behind them, which is essential for identifying and correcting biases. This transparency is not only beneficial for developers but also for users and stakeholders who rely on AI systems for critical decisions. By making AI systems more transparent, we build trust with stakeholders, ensuring that they feel confident in the technology's reliability and fairness. Transparency also aids in compliance with regulations and ethical standards, which is becoming increasingly important as AI systems become more prevalent in various industries. Lack of transparency can lead to mistrust and misinformation, which can ultimately hinder the adoption of AI technologies. Thus, transparency is a foundational element that supports ethical, reliable, and user-friendly AI systems. Explainability refers to the degree to which an AI system's decision-making process can be understood by humans. It is a subset of transparency but focuses more on the why behind decisions rather than just the what. While transparency might reveal the components and data used, explainability provides insights into how those factors lead to specific outcomes. There are different types of explainability, including post hoc explainability, which assesses decisions after they've been made, and intrinsic explainability, which builds understanding into the model from the ground up. Explainability is crucial in AI systems because it allows users to comprehend and trust the outcomes. It also enables developers to refine and improve AI models by understanding their behavior. Examples of explainable AI include decision trees, which offer clear paths to conclusions, and certain neural network models designed with interpretability in mind. By prioritizing explainability, we can create AI systems that are not only powerful but also aligned with human values and expectations. Achieving model transparency involves several techniques and practices. One effective method is the use of interpretable models, which are simpler and more understandable by design, such as linear regression models or decision trees. These models provide a clear path from input to output, making them inherently transparent. Another technique is data visualization, which communicates complex data and model predictions in a visual format that is easier to interpret. Techniques like feature importance graphs and confusion matrices can provide insights into model behavior. Documentation is also key. Detailed documentation of model development, assumptions, and limitations ensures that all stakeholders have a clear understanding of the model's capabilities. Transparency can also be enhanced by using explainability tools such as LIME, local interpretable model agnostic explanations, and SHAP, Shapley additive explanations, which help clarify how models reach specific decisions. By adopting these techniques, we can ensure that AI models are not only transparent but also robust and reliable. Balancing transparency with performance presents significant challenges in AI development. Often, the most transparent models, like linear regressions, may not achieve the same performance levels as more complex models, like deep neural networks. These complex models, while powerful, can act as black boxes with opaque decision-making processes. The trade-off between transparency and performance is a key concern. Increased transparency might lead to reduced model accuracy or efficiency if not managed correctly. However, it is essential to recognize that sacrificing transparency can result in ethical and practical issues. To overcome this, developers can use strategies like hybrid models that combine transparent and complex elements, or ensemble methods that use multiple models to improve performance while maintaining a level of transparency. Another approach is to incorporate explainability techniques that do not compromise performance significantly. By strategically balancing these elements, AI systems can be both high-performing and transparent. Visualization tools play a crucial role in enhancing the transparency of AI systems. By converting complex data and decision processes into visual formats, these tools make it easier for users to understand and interpret AI models. Two popular tools are LIME, local interpretable model agnostic explanations, and SHAP, Shapley additive explanations. LIME creates simple models that approximate complex models locally, making individual predictions understandable. SHAP assigns each feature an importance value for a particular prediction, offering insights into model behavior. Visualization helps in interpreting model outputs, identifying biases, and understanding the influence of individual features on predictions. Effective visualization not only aids transparency but also facilitates communication between data scientists and stakeholders. Case studies have shown that using these tools can significantly improve the trust and acceptance of AI systems in sectors like healthcare and finance, where understanding the decision-making process is critical.
Regulatory frameworks play a vital role in enforcing transparency requirements in AI development. These frameworks are designed to ensure that AI systems operate ethically and are accountable to stakeholders. Transparency requirements often mandate that AI systems provide explanations for their decisions, particularly in critical applications like healthcare, finance, and law enforcement. Key regulatory bodies, such as the European Union's General Data Protection Regulation (GDPR), have specific guidelines on AI transparency and the right to explanation for users. These regulations impact AI development by necessitating changes in how models are built and documented. Compliance with these standards not only ensures legal adherence but also promotes ethical AI practices. Developers must be aware of these frameworks and incorporate transparency and explainability into their AI systems from the outset. By doing so, they can mitigate risks, enhance user trust, and contribute to the development of more responsible AI technologies. Examining case studies of transparent AI implementations provides valuable insights into the practical benefits and challenges of transparency. In the healthcare sector, for example, transparent AI systems have been used to improve diagnostic accuracy while providing clear explanations for their decisions, enhancing trust among medical professionals and patients. In finance, transparent AI models have helped in credit scoring by offering understandable criteria for decision-making, thereby increasing customer satisfaction and compliance with regulatory standards. These examples highlight the positive impact of transparency on industry practices, including improved trust, compliance, and decision-making accuracy. Lessons learned from these implementations stress the importance of incorporating transparency from the beginning of the AI development process. They also demonstrate that while achieving transparency can be challenging, the benefits far outweigh the difficulties. These case studies pave the way for future advancements in AI transparency and demonstrate how ethical AI practices can be integrated into various industries. As AI technology continues to evolve, several trends are emerging in the field of transparency and explainability. One key trend is the increasing role of AI governance, where organizations establish policies and frameworks to ensure ethical AI development and deployment. Advancements in explainability techniques, such as more sophisticated visualization tools and model-agnostic methods, are also gaining traction. These developments are expected to enhance the interpretability of complex models without compromising performance. The impact of these trends on AI ethics is profound, as they promise to improve the accountability and fairness of AI systems. Future predictions indicate a growing emphasis on integrating transparency and explainability into AI models from the outset, rather than as an afterthought. As AI systems become more complex and widespread, the demand for transparency will likely increase, driving further innovations and setting new standards for ethical AI practices. These trends represent an exciting frontier in AI development, with the potential to transform how AI systems are perceived and utilized across industries.
As we conclude our exploration of AI ethics, building transparent AI systems, it's clear that transparency is not just a desirable trait but a necessary one for the ethical development of AI technologies. We've discussed the importance of transparency, various techniques to achieve it, and the challenges that come with balancing it alongside performance. Looking ahead, the trends in AI transparency and explainability promise exciting advancements that will shape the future of AI. I encourage you to apply the skills and knowledge gained today to develop AI systems that are not only powerful but also transparent and accountable. By doing so, you'll contribute to a more ethical and trustworthy AI landscape. Thank you for joining us on this journey into the world of transparent AI.